right, good morning, everybody. We are going to finish up Chapter 3. Shouldn't take us too terribly long. I've added a few problems. That way you can work some problems at the end. Be sure that you are up to speed with what we go over today. So next week's kind of a big week. We have lab. So you have two labs. There's empirical formula. So from Chapter 2, when we talked about empirical formulas, we're going to derive the empirical formula for magnesium oxide. So you're going to be doing that in lab. And you're also going to be making aspirin. So you're going to have to multitask very well. So keep in mind that you guys get, some weeks off. So be in there ready to go and good attitude. And we have a test next week. So you have Monday, all your homework is due. And then Wednesday will be the exam. So just like last time, I'll post answer keys Monday after class. I will say, though, whenever I take up the homework on Monday, we'll be reviewing and taking up homework. If you don't have it within that class period, I won't take it after that. Okay, so when I call your name, if you don't have it, then it's not fair for you to sit in here and get it all done and then come to me afterwards. So you need to have it when I call your name for full credit anyways. So just to be clear on that. Okay, so we have looked at, this is kind of a segue into the next unit. Okay, it's just to kind of get you used to looking at solutions instead of solids. So far we have been doing calculations. We now have looked at balanced equations and we've converted from grams to moles, moles to grams. Okay, but in reality, when we are performing chemical reactions in the lab, a lot of the time they're in solution. Okay, so probably 75–80% of the time they're in solution. Okay, and so we have to be able to know how many, what our solute and our solvent is. So we'll talk about that here in a second. We have to be able to do calculations based on what we call concentration or based on the molarity, or there's lots of different ways that we express concentration. Okay, so just kind of a general idea. Most people already kind of know this, but a solution is a mixture of two or more substances that are dissolved in each other. So I should really say each other or one another. Okay, the solute is what is present in the smallest amount. Okay, so if you think about even a sodium hydroxide solution, so we add water to sodium hydroxide, and the water, in most cases, about 99% of the time, water is a solvent. Okay, so solvent is the substance present in the larger amount. Okay, anytime you see an aqueous solution, all that means is that the solvent is water. Okay, so it may not tell you water is the solvent, but if it says an aqueous solution, you know that water is a solvent. It's a very common solvent, obviously. Okay, so we look at the concentration of a solution, basically tells us the amount of solute that we have in the solvent. Okay, so one that usually pertains to people here in the South, but our sweet tea. Okay, so if you think of the sugar, that would be your solute in the sweet tea. Okay, so depending on how much sugar, how sweet you like your tea, you add more and more sugar, and it becomes more concentrated. Okay, if you don't like it as sweet and you don't put as much sugar in there, then it's less concentrated. So that's kind of the idea. So the sugar in the tea is what is the solute. Okay, and like I said, this is kind of a beginning to what we're going to be talking about for a lot of Unit 3. But today we're going to cover two ways that we can express concentration. Okay, so we need to know as chemists or students or whatever, you need to be able to relate and say, I have a 1 molar solution of whatever that solution might be. That has to mean something to you. Okay, so you need to all be on the same page with respect to solutions. Okay, one of the ways that we express concentration is percent by mass. Okay, so on this exam we're going to have two. There's going to be percent by mass and molarity. Okay, and we'll get to molarity here in a few minutes. Okay, percent by mass of the solute is basically taking the mass in grams. Okay, so we all know our unit of mass is in grams here. So we take the mass of the solute and divide it by the total mass of the solution times 100. How I like to think of this is just like part over whole again. You take your solute, whatever the mass of that is, over the total mass of the solution. Okay, and then you times it by 100. Okay, the total mass of the solution is going to include the solute, the mass of the solute, and the mass of the solvent. Okay, you have to be careful with the wording in the problems here. That's probably the most common mistake. Usually most students remember this part. But if it tells you that the mass of the solution is 100 grams, then that means it's already giving you the total mass of the solution. Okay, so you wouldn't have to add your mass of solute. So we'll look at examples here. And we've got examples, I think, on the practice test, too, that's like that. You'll see this written as percent W over W. That's another way you'll see this written, so don't get confused. Okay, so we have a salt solution. So we're going to take 25 grams of sodium chloride and dissolve it in 87 grams of water. And we want to find the percent by mass. Okay, so whenever you're in the lab, and now that we're kind of going through this, when you're in there next week, I want you to think about that someone had to prepare all of these solutions for you. So either me or Miss Janice or some of our other lab assistants have had to go in and prepare solutions. So if we prepare a 10% solution, we've been doing this calculation to figure that out. Okay, so this is all the solutions that you see in the lab, they've had to be prepared by someone. Okay. All right, so how we would do this, we would take the mass of the solute. So we're given 25 grams. Sodium chloride is our solute. Okay, a hint here, if you see water, it's automatically, I'm not going to trick you with that, it's your solvent. Okay, so it's going to be your 25 grams for the solute. Okay, and then it's over the total mass of the solution. So you have 25 grams of the salt that you've measured out on the balance, and then you have 87 grams of water. So you have to add 87 and 25. This is your whole solution, okay, the mass of it, times 100. Okay, and so you get 22.3% for this problem. Okay. Another way that we can work this problem, so I've talked about how we can rearrange equations. So as long as here we've got 3 different variables. Okay, so if we're given 2 of the 3, we can always solve for the other. Okay, so the previous problem was probably the easiest. You just plug in, just as is in the equation that we went over. Okay, but here we want to know what mass of sodium hydroxide, okay, that's going to be our solute, okay, is required to prepare 250 grams of a solution that is 8% by mass, W over W. Okay, so this becomes handy. So sometimes you're given a formula, or in an experiment it says, you got to have 8% solution and you're going to need about 250 grams of that solution. Okay, so you kind of have to, all you do is you rearrange the equation. Okay, and so you solve for, okay, how much NaOH am I going to have to measure out? Okay, so we would have to, the main thing, we're in percentage, so we've got to move our decimal place back 2 places to go back to 0.0800. Okay, we have to get out of percent there. Okay, and then we're going to be solving for grams of NaOH, and then we already are given the total mass of the solution, okay, which is 250. Okay, so if we rearrange here, so basically we end up multiplying 0.0800 times 250. We end up with 20 grams of NaOH. Okay, you can also do it this way. If you see it better this way, you have a total solution. We know that a percentage is 8 always out of 100, so it'd be 8 out of 100 here. So either way. Okay, but this uses the equation that's up here. Okay. The second common unit of concentration is called molarity. Okay, it's given the symbol, the uppercase M, so don't get this confused with moles. Okay, this is the most common. This is one that I will use the most in class. So we'll be hitting this one hard for the rest of the semester, really. Okay, so the first thing you want to know is the equation for it. So molarity is the number of moles of solute. Okay, so it's moles. Now we're thinking in moles, not grams. Okay, earlier we were looking at grams, over the number of liters of solution. Okay, so you want to get very familiar with this. Molarity equals moles over liters. Okay, and we can also, we'll look at this more next unit, but millimoles per milliliter. Okay, a millimole is 1/1000th of a mole. Okay, so milli, and so you can also be in milliliters. But if you're in milliliters, you have to be in millimoles. Okay, so go ahead and just put this one up here. So we want to calculate the molarity. So we want to see, remember, these are ways to express concentration. So after today, if I say it's a 1 molar solution or a 2 molar solution, that should mean something to you. So we want to calculate the molarity of a solution that has 12.5 grams of sulfuric acid. Okay, so that 12.5 grams of the acid will be our solute in 1.75 liters of solution. Okay, so if we look here at our equation, we have to have molarities equal to moles per liter. Okay, but you're given grams, right? Okay, but from chapter 2 and chapter 3, we know how to convert from grams to moles. Okay, so that's all we're doing here. So we're just abbreviating sulfuric acid as H2SO4. Okay, so we add up the formula weight for H2SO4. It should be about 98.1. Okay, and so all we're doing in this first step is converting from grams to moles. Okay, so once we find moles, now we're ready to plug in our moles and then the liters from the equation to give us the molarity. Okay, so the simplest way I could ask this is if I just gave you the moles and gave you the liters, and then you just divide the two. Okay, but this way, we're going to see some more here in a few minutes. Okay, but we would convert to moles first and then put that over liters. Okay. All right, first I want you, obviously we're talking about molarity equals moles per liter. Okay, but a lot of times students will get on an exam and they won't realize what equation to use. Okay, so I want you first to read this and think about how you could use the equation molarity equals moles per liter and find the mass of the solute, which is calcium nitrate here. So I want you to work this one for a few minutes and see what you come up with. Everybody got the numbers down real quick? I gotta go try to find my. Be right back. Okay, so if we look at our equation, we have three variables: molarity, moles, and liters. Okay, so if we look at what we're given in the problem, we're given the liters of the solution, and we're given molarity. Okay, so this uppercase M here, this is molarity. Okay, so we have two of the three variables, so we can actually just rearrange. So if we rearrange this, we get molarity times liters equals moles. Okay, and this right here is going to be very valuable to us come next unit. Okay, so I would star this, circle it, whatever, because we're going to be using this all the time, and we're going to be plugging it into a more complicated equation, and for some reason students just don't see that. I don't know why, but they forget that the molarity times the liters gives us moles. Okay, so you'll constantly want to come back to that. Okay, so if we take our molarity, times the liters, all right, what did you guys get for number of moles? 2.80. Moles. Okay. All right. Since we can convert from moles to grams or grams to moles, and we know how to do that hopefully efficiently by now, we can now just take our moles So we have to add up, so it's important here that you know how to add up the molar mass of compounds. Okay, so what did you guys get for the molar mass? Anybody? Anybody have it added up yet? Okay, I'll give you. Okay, very good. Yeah, I've got 164.09 or 164.1. Yep. Okay, so remember when you add this up, we have a polyatomic ion. Okay, so that parenthesis here is multiplied, so we have 2 nitrogens and we have 6 oxygens that you have to add up. Okay, so what you guys get about 459 grams. Calcium nitrate. Okay, and so to get a 0.800 molar solution, that is 3.50 liters, we would need 459 grams of calcium nitrate. Okay, any questions on this one? Mm-hmm. Oh, talking about the formula? Yes, so this is a polyatomic ion. Whenever these are parentheses, they kind of look like carbons here, but they're parentheses around this. So this number on the outside means you have 2 of this polyatomic ion. So you have a 1 understood here. So you would, when you're adding up, you'd have 1 calcium, you'd have 2 nitrogens, and then you have 3 times 2 oxygens. So when you're adding up, you'd have 6 oxygens, 2 nitrogens, and 1 calcium. No, this, when you're adding this up, that's where we got this number right here. Yep, that's your formula weight, or molar mass. Mm-hmm. Okay, so I already mentioned this, but here I have it starred for you. But one of the reasons that molarity is commonly used is because of the calculation that we just did on the previous slide, because we can rearrange the equation, and molarity, so big M times liters, equals moles. Okay, so we're going to be needing to find moles of a compound, and then we're going to convert it to another compound. We're going to use an equation here in the next unit. So this is very important. And if we're looking at small scale reactions, so a lot of times, especially in academic laboratories, we're working with milligrams of material. Okay, so if I was to do my calculation and I get 0.000001 moles, okay, that's not really very efficient for me. I would rather convert to millimoles to a smaller quantity. That's just more, you just can relate to that better. Okay, the last equation we're going to look at, I want to first say you cannot use this equation when you have a chemical reaction. Okay, we cannot convert from molarity of one to another with a chemical reaction using this equation. Okay, so I have, probably some of my highest percentage of missed questions is trying to do that in the next unit. They try to just plug this in and solve. Okay, the reason we can't do that is because this does not take into account our coefficients in the balanced equation. So the number of moles does not take into account that ratio. Okay, but when this is useful is if we are trying to dilute a solution. So all of you have done this, whether it's, you have done it in the chemistry lab or you've done it in your home. Okay, so if you dilute, once again, going back to sweet tea, when you're adding water to it, you're diluting it. Okay, so the same way that fountain drinks are made, so they dilute the sugar and the syrup. Okay, so our relationship that we're going to use for diluting is M1V1 equals M2V2. That's our calculation. You can think of 1 as initial if you'd like to. So M initial, V initial equals M final, V final, if that's the way you'd rather look at it. You can also, so molarity is for the big M there, and then V is for volume. Okay, you can use milliliters or liters here as long as you are consistent. Okay, so if I give you one volume in milliliters and one in liters, you need to convert one to the other. You have to be consistent with what you put into the equation. Okay, so we have 10 milliliters of a 12 molar HCl solution. Okay, and this is added to enough water to give 100 mils of a solution. So now we want to know what is the concentration of this final solution. Okay, so we do this a lot in the chemistry lab, and we'll need different concentrations, so we'll dilute it, but we have to calculate how much water or how much solvent do we need to add to dilute it to the proper concentration. Okay, and so we use our M1V1 equals M2V2. So if we go through here, so this is our M1, our M initial. This is our V1. Okay. We're looking for concentration, so we're trying to find our M2. And this is our V2. Okay, so you can rearrange the equation first if you'd like, or you can just plug in the values and then rearrange, however you like to do your algebra there. Okay, so if we're going to isolate M2 by itself, so we've got to divide through by 100. Okay, we're given milliliters for both volumes, so we can go ahead and use milliliters. We don't have to convert one to the other. Okay, so this is what we're doing here. So we have our M1 and V1 and divided by our V2. Okay, and so our M2 equals 1.20 molarity. So that would be our resulting concentration. Okay, I want you guys to work this one using the M1V1 equation. Everybody get 0.333 liters? Okay. So the key here is to be sure you've labeled your M1, V1, and find out what you're solving for. So actually be finding V1 this time. Okay, so all we would do is rearrange. So V1 is going to be equal to our M2 times V2 over M1. Okay, so we just plug in the values. So really the only mistakes I have with this is just accidentally getting something backwards or just or a calculator error. Okay, but once we plug in, do the math, pretty simple here, we get 0.333 or 333 milliliters. Okay, any questions on anything we've hit so far? Okay, I've come up with a few more problems for extra practice on just the solution portion. Okay, and the last one's actually not complicated at all, but just a little bit different. So I want you guys to work this one, and I'll kind of see how you're going. There's 3 of them, so we'll work this one, then we'll go over all 3 of them. We'll work all 3, and then go over them. So you won't have this in your PowerPoint, so I added these yesterday. So go ahead and work this. You'll need your one thing that just for practice to try to help you with naming, because I know it's been a while, but the naming is going to be a significant portion of the exam. So what I have done is I have just written sodium phosphate. Okay, you guys need to take that name and convert it to its formula. Okay, so you got to remember how to do that kind of stuff for the exam. Okay, so you have to take sodium, has that +1 charge. You got to go find phosphate on your polyatomic ion list. Okay, if you can't write the formula, then you're going to have a hard time getting the molar mass of the compound. Okay, because if you don't write it correctly, then that's going to be wrong as well. Okay, so this is kind of a hint to what I could do on the exam to be sure that you know both. You know how to name and know how to calculate. Mm-hmm. Do what? You could use it here, but it's going to add you another step. So, yeah. Yeah, here you wouldn't want to actually because you're not given like another volume, so you can't. You got to use your molarity. Yeah. Yeah, it's confusing, but yeah, it's just saying you're just diluting it. There's no chemical reaction, so. Question? Okay. All right, you have to take, so when you have the name, so the first thing you have to recognize is you have a metal, okay, and then there's 3 classifications. So there's 1 when you have nonmetals, and the other 2 when you have a group 1, 2, or 3, or when you have transitions. Okay, so sodium is obviously a group 1, 2, or 3. Okay, so when you name it, all you do is name the metal and name the anion portion, so phosphate. Okay, so now you have to take, let me borrow your pencil. You have to take Na, okay, it's in group 1, so it forms a +1.
Right.
Okay, you have to recognize that phosphate is a polyatomic ion. So you go to your list. So I handed one out one day, or you can look in your book, okay? But when you look, you're going to find that it's I'm sorry, let me do that. It's PO4, but the charge is 3-. So that's on the list. And I will give you that list on the exam, so you don't have to memorize the polyatomic ions, okay? For these, all we have to do, the easiest way, basically the total charge has to equal 0, okay? But one of the hints is that
3PO4.
Exactly. One of the hints here is that you can just take that number and take that one here, and you end up with Na3PO4.
Okay,
Yep.
great.
Yeah, so first write out what's your formula for molarity, and then see what you need to find. Okay, so molarity is equal to what? So big M equals moles over liters. Okay, so I'd write that out first. So write out molarity equals moles per liter. Okay, so in your problem, you're asked to find this, and you're given the liters. So I'd go ahead and just off to the side here, plug in my 2.5. Okay, now we have two missing variables. So the only thing we can do is we've got to get this grams to units of moles. So you're going to take this number, and you're going to add up its formula weight, and you're going to convert from grams to moles, and then once you get moles, plug it right there. Yep. The liters? Oh, that's just a word. You don't worry about that. Yeah, you can't use the M1V1. Okay, this is just a problem. You'll see that a lot. It's just asking you for the molarity if you use so much and have so much solution. So yeah, M1V1, you've got to be given two molarities or two volumes in order to do it. So yeah, you're just finding molarity. Yeah. Mm-hmm. Yep. So you write out molarity equals moles over liters. You go back and look. So you write out moles because you got two M's there. Yeah, just so you don't. Molarity is uppercase M. Yeah, this is molarity, that's moles. That's okay. Okay, first thing I do when I have that written out, I go back to my question and I see what could I plug in that I know. Okay, I'm given 2.50 liters, right? Okay, so I know that. So I go ahead and kind of write that out in there. Okay, and then I see, okay, I'm looking for, okay, this should be molarity.
Okay.
Yeah, right, molarity, and that's moles. Okay, so now I'm finding molarity. That's what it asked me, right?
Yeah.
Okay, and I'm given grams, but I know I can't plug grams in there. I got to convert to moles. So I take my 355 grams. Okay, but now I have to know it's sodium phosphate, what the formula for it is. Okay, so I can kind of show you, and maybe easier than anything. Okay, but it's our second classification for naming. So we see that sodium's in group 1. Okay, so group 1 metal, so it has a +1 charge. And then you have to recognize that phosphate is on your polyatomic ion list. That was handed out to you. And when you look it up, it has a charge of 3-. Then you just swap these numbers, the swapping states. I don't know if you remember seeing that.
Okay.
So you get this. Okay, so now you know the formula. So now you've got to add up the molar mass. So you go to your periodic table, and you're going to add up 3 sodiums, 1 phosphorus, and 4 oxygens. And that is going to go, see that's grams, don't forget to put your units. That number is going to go here, and whenever we use the periodic table, it's always out of 1 mole.
Okay.
So you're going to divide this number by whatever you add up. That gives you moles, and you're going to plug it right there and divide by 2.50, and that gives you the molarity.
Make sure I got that. So swap that out, and you go 3, 1, 4, right? You add those together.
Okay. Now you just move the 3 there and the 1 there.
Oh, okay.
Yeah. This is a polyatomic ion, so if you had more than 1, so you would have to put a 2. So you can write it like that if you want to.
Okay.
Yeah.
Is that 3 times?
Yeah, you have to put parentheses. No, you just have 3 sodium atoms, and you have 1 phosphorus and 4 oxygens.
Oh, okay.
Yeah.
So it's 3 times 4. Okay.
Mm-hmm.
And then you plug whatever that is right here.
You add it all up from your periodic table, and that's going to give you moles. So you're going to be able to cancel this, and that gives you moles of sodium phosphate.
Okay.
Then you plug that moles right there. and divide it by liters to give you molarity.
Okay, I got it.
Okay.
Thank you.
Mm-hmm. Yes.
Having the same problem.
Okay.
Just figuring out the moles. I've got this right here.
Okay. What you want to, real quick, so you want it to be a neutral compound. So you have your charge, that's right. But you have a +1. So to get your formula, you swap states. Remember I was talking about that? You move a 1 over and a 3 there. So your final formula ends up being that. Okay. So now you take your 355 grams Na3PO4. So you have grams Na3PO4 and 1 mole. Okay, so now you just add up the molar mass. You go to your periodic table.
You're adding up that 22.98.
Yep. Yep. So you've got 3 of them. So you would have 3 times the 22 point, or what am I thinking of? 22.9, is that what it is? Then you have 1 phosphorus and 4 oxygens. That is the number that goes here. That's your molar mass, also called formula weight. Okay, and that's how you get from grams to moles. Always. So you use that number from the periodic table. And it's always out of 1.
And then am I going to divide these two?
Exactly. So when you get your moles, so whatever's left uncrossed out on top is moles. Okay? So now you need moles, right? So you have moles and you plug it in right there and divide by 2.50, and that gives you molarity. Yep. So don't get, that's molarity, so big M. So, and this will be moles. Yep. Mm-hmm.
We just assume that you start off with water because you're diluting CH3.
Yeah, I think diluting is throwing you guys off. You're not using, are you trying to use M1V1? Yeah, you don't need, you just need the 1 liter. So you don't really know. It's not telling you here. If you were using M1V1,
To get the molarity, use 1 liter of water to start off to get the molarity.
no, you're going to use moles. So you convert grams to moles. Did you do that? Okay.
Put it in the formula.
And then you just take moles over the liters that's given to you. Yeah, you don't have to know 2 volumes. Only time you need 2 volumes, like initial and a final, is when you're using M1V1. Okay, we're going to work this one real quick so we can move on to the next one. Okay, we're going to use molarity equals moles over liters. Okay, you want to know, you have to know the formula first. And then what I always do is I go back to my problem and I see, okay, what am I given? What can I go ahead and plug in? So what do I know? So I know the liters. 2.50. Okay. And then I'm given grams. Okay. I can't just plug grams in. That's a common mistake. Grams is not the same thing as moles. So all we're going to have to do is convert from grams to moles. We have 355 grams. Okay. Okay, so I got my formula because +1 charge for sodium. Phosphate has a 3 negative charge. If I swap my states here, I get Na3PO4. Okay, so to convert from grams to moles, or moles to grams, either way, I always have to use that formula weight, also known as molar mass. And if you have a covalent compound, we can call it molecular weight. So there's 3 different terms that can be used. Okay, so we're going to add up 3 sodiums, 1 phosphorus, and 4 oxygens. Okay, so what did you guys get for your molar mass? Yes, ma'am. And 1 mole. Okay, remember, whenever we convert grams to moles, moles to grams, it's always out of 1 mole, okay, because that's what our periodic table is based on. Okay, so we cancel our grams. So we divide 355 by 163.94. Okay. All right, so what did you guys get for that? Okay. I got 1.7 or 1.6, yeah. So we'll just 1.7 moles. Okay. So now we found our moles, which we can now go and plug it in. We get 2.7 moles. Okay, so I think I ended up with about 0.86. I use the, did you get 866 or 868? Okay. Whoa. Molarity. And then if we were to be technical here, we have a sodium phosphate solution. Okay, any questions? All right, here's the next one. Work this one. Feel free to ask me questions, walk around. right, what'd you guys get for your answer? Okay. All right, so we use our M1 V1 equals M2 V2. Okay, so commercially we have concentrated HCl, which is 12 molar. Okay, so you can rearrange to start with however you want to. So we get M2 V2 over 1. So molarity final. Okay, we're just, like the equation says, we are diluting the HCl. We don't want it as concentrated as 12 molar. We want it to be 1.50 molar. And we want it to have 2 liters. Okay, and we're starting with 12 molar. Okay, so we're going to need 0.250 or 250 milliliters of concentrated HCl. All right, any questions on that one? Yes. Yes. Yep, it's like this. All right. See what you come up with for this one. So you're given a density. This might throw some of you, maybe not, but see what you can come up with for this one. First, you got to figure out which equation that we talked about today that you want to use. So, hint, I'd go back to the very beginning of the lecture. I'll give you another hint. So this is like percent WW. You're going to want to use percent by mass, so be sure we did a problem very similar where we were given the percentage. So the first thing we had to do was move our decimal place back. We get 0.180 here. Okay, ammonium chloride is the solute. So NH4Cl. We don't really have to use the formula, but just you're given the total volume of solution, but in order to use our percent by mass, it has to be in grams. Okay, so that's where density is going to come into play. 2. Yep. Yep, that number is times 100, so you just move it back 2. Think about how your units could cancel. Like we need this grams right there. Need to be in the units of grams. And you're given the volume of the total solution and the density of the total solution. If you think you've got it, put your hand up. Before I put it up here, I want to see if somebody can get the answer first. It's fine. Yes, ma'am. Yeah, so you put in your... Yeah, you just want to be sure and show me. You got to it somehow, but...
Yeah, it's right here. It's
Okay, so...
Arrange it, so basically...
But where did you get that from is what most people
right here.
don't know how to do.
50 milliliters times the density.
Okay, yeah, but you'd want to show me like how the units canceled there, which is exactly right. So you have that 1.05 grams over 1 milliliter basically, and so the milliliters cancel.
Yeah, these two cancel, which leaves you with the grams, all the grams.
Yes, ma'am. Y'all get it? Which one? Hang on. Okay, this is right, and that's right. Okay, so you just plugged it in. Okay, yeah. So you would just want to be sure you put your, if you wrote out the, the final grams of ammonium chloride.
That was my equation. That's my density problem.
Okay. Really? Yeah. He got it.
Okay, yeah.
That's the right answer. Yep. Good job. Very good. Yep. And you just want to go to round up 3 sig figs. Okay, and you're given 3 significant digits everywhere, so you want to have 3 in your final answer also. Okay, so some of you did get it, so good job, but we're going to go over it anyways here. Okay, we're looking for the mass of our solute. Okay, so our solute here is ammonium chloride. Okay, so somehow we have to get this and this number into grams of total solution. Okay, so how we can do this is we take our milliliters of solution and we multiply it times the density. Okay, because our units for density for our solution, okay, it's understood it's per milliliter or per 1 milliliter. So we can cancel our milliliters. And what do we end up? 472? 472.5 or really 473, but okay, so now we plug this number here. So we have grams of solution. We're going to plug that number in here. Okay, so when we rearrange and solve, so we'll end up multiplying 0.180 times, so go ahead and do that here. So we have 0.180. This is our x, or what we're solving for, divided by 72 grams solution. Alright, so we need to isolate our variable here. So 0.180 times 472.5, we end up with 85.1 gram of solute, or ammonium chloride, because that's our solute. Okay, so we had to look for a common unit. So density is in the units of grams and milliliters, so it has a mass and a volume quantity, and it becomes very useful when we're looking at solutions. And here in our next unit, we're going to have to use density a lot, because you need to know the density of your solution, and it will help you in the calculations as well. Okay, so our common unit was those milliliters, so we can cancel those, and we're left with grams. We're looking for the mass, so we know it has to be in grams, and we just plug it in. So the only difference is that we had to kind of find the mass of the total solution. It wasn't just given to us there. Let's go real quick and show you guys, be sure everybody knows what is due on Monday. Okay, real quick, listen up. Okay, you have this naming worksheet. It looks like so. It's pretty long. Okay, so you should get lots of practice. Hopefully you've been keeping up with it so you haven't forgotten how to name. Okay. You've also got Chapter 2 and 3 problems. It starts with balancing, and then goes through to molar mass, and then all of the stoichiometry. Okay. And that's it. This is actually the practice test, so we'll do that on Monday. So we're going to work a lot of problems for review. You have lab next week. Wear proper attire. Bring questions so that you all can do well on the test on Wednesday. You guys have a good afternoon.